Hello, my name is Vadim Lukyanov. I'm an engineer at SafeEquip, and today we're going to discuss pressure. So let's start from the definition of pressure. It's by the Longman Dictionary. It's the force produced by the quantity of gas or liquid in a place or container. So it's basically come from the word press, so which is press, yeah, just to put some, make some pressure, yeah, it's to press firmly something. And when we are talking about the engineering part, yeah, we are the nitrogen and oxygen machine manufacturer, and we are talking about for in our field, in engineering field, we have to measure it somehow, yeah, and we measure it in here we measured PS in PSI, so which stands for pounds per square inch. It's very important that we are talking about the pressure, and we are talking about some space where we put it, yeah, because if I press the same like let's say the bottle, yeah, which small bottle, and if I press this bottle through the book, for example, to this surface, it's gonna make not so much pressure in any given point. If I press it this way, it's gonna make pressure on this point is higher. But if I get, for example, a needle, yeah, or something very tiny, and if I press and I put this pressure, so you know you can feel it if you put the your hand, it's gonna make more pressure and it's gonna damage maybe even your hand. And it's very important then we are using the pressure per square inch, yeah, per some area. So this is the, let's say this is inch, yeah, this is 1 inch, this is 1 inch, and it's gonna be 1 square inch. And if we put 1 pound, which is about this size, and if we put 1 pound to this surface, that's gonna be 1 psi, 1 pound per square inch. And it's very important to understand this concept of pressure because, for example, all our engineering stuff, everything we're gonna talk next, we're gonna always use the pressure. Yeah, it's a very important number in all our calculations in equipment. So, and this how the pressure press to the bottle or to the tank. Yeah, when we have a tank, it's all the tanks. For example, this tank, yeah, they design it, and the engineers is always calculating how much pressure it can withstand, yeah, and it's important in our calculations. So we have pressure per square inch, yeah. Some people call it just pounds, yeah. Some old school engineers can call it pounds, which means like when you say I drove 80 miles, yeah, you don't say 80 miles per hour, you drove 80 miles, yeah. So sometimes the engineer can tell like it's we had 100 pounds pressure, 80 pounds pressure, so it means pounds per square inch, yeah. Pounds per square inch, it's in US, it's but all over the world they use different type. It's bar or atmosphere. 1 bar almost equal to 1 atmosphere, and it's equals 14.5 psi. So it's very straightforward conversion, so there's not big of a deal, but we use psi here. Okay, so and it's important to don't mix it, to don't be like confused with the flow. So for example, this bottle can have like, let's say 10 psi pressure inside of it, yeah. It's actually, if you put if you shake it well, it's gonna be, you will feel the pressure is increasing, yeah. And you can have pressure here is the same as a pressure in a huge for example 5 100,000 gallons tank, yeah, and it's gonna be the same pressure, but the amount of water or gas is gonna be different. So, okay, let's go next. We in our nitrogen and oxygen machines, we need certain amount of pressure. We need a certain pressure to be on inlet of the nitrogen machine. So why is that? And it's gonna be different for nitrogen and for oxygen, slightly but different. So let's talk about nitrogen machine. So nitrogen machine is ideally works at 110, 120 psi. I will explain you why. So inside the generator, there is a carbon molecular sieve. It's in my book. It looks this way. It's you can see it as a coil. Yeah, it's some simple coil, but have a very specific structure to catch the molecules of oxygen. So the oxygen will stuck in it. So let's look at this. It's the way like when it goes through. Now our nitrogen generator, when the air goes through, and if pressure is not high enough, it will not press the molecules of oxygen into the molecular sieve. You see, and it's not gonna be stuck there. So it's gonna fly over, and it's gonna go together with the nitrogen, and at the end you're gonna get less purity of the nitrogen, yeah, because the residual oxygen will be more. You see, that's very important to understand. When we go through the machine, we have to have the pressure, yeah, we have to press the molecules of oxygen into the CMS so it's stuck there. Will the nitrogen machine work with the lower pressure? Yes, it will, but just not as good as it engineered for. It's not as it's supposed to. So you see, we have I have here some test reports. We at some point we test all our CMS, carbon molecular sieves, for the machines we are building. So what we can see in this test results. So I take the CMS, I put it inside the machine, and I test how much nitrogen I gonna get at each purity and with each pressure. So I get and what results I have. So I will try to put this the test results in the description below, so you can click a link and you will see on Google Disk the test results which I got, and I made it for 99%, 98, 97, 95%. Yeah, let's talk about, for example, 98%. Yeah, so we have here, you will see on the description. So it's 70 psi, 90 psi, 100 psi, 150 psi. So you see, at 70 psi we will still have some production of the nitrogen. Yeah, for this it's for metric tons. What is the production of the nitrogen in cube? Just what is the production? Yeah, just these figures is for production of nitrogen. So we're gonna produce on the same exactly nitrogen machine nitrogen 98%, 290, or if we increase the pressure, it's gonna be more. If we increase to 100 and it's more, and we increase to 150 and it's gonna be more. So ideally we need 110 to 120 psi to be inside the column, the nitrogen adsorption column. You see, so it's the best way to work is to have 145 psi air compressor, because we're gonna have some drops in pressure, because there is the line, there is supposed to be tank, and it's supposed to be some losses. Yeah, it's first, but the more important, when we're talking about 145 psi air compressor, it's not gonna work like at 145 psi. At 145, it's gonna shut down. So consider it as a AC, yeah, at your office or at your home. When you put AC at 75 degrees, it's not gonna stand like 75. It's gonna stand. It's gonna stand below that. Yeah, it's not gonna go exactly at 75. When there is a spread like 1 or 2 degree, which you can change in settings, when there's 2 degree difference, it will start to work. Same with air compressor. Air compressor will work until 145. When it's reached 145, it will stop. So, and it will start working again, usually at 125, 130, something like that. So you ended up actually in your air tank, you will end up with 135, 140 at the best, yeah. So, and still our nitrogen machine work as a pressure swing adsorption, yeah. So it means there's swing of adsorption, and the cycle is 40 to 60 seconds, depends on the machine. We set it on factory, but mainly it's 60 seconds, let's consider this. And that's where the cycle starts and stops. And each start of the cycle, we need more actually air than it's required. We need more in the peak, like for the 5 seconds, we need more. So that's why we have an air tank before the nitrogen machine. So, and it's still gonna drop. So we have all these losses, and we ended up with 120 inside the adsorption tower, where the adsorption actually performing, where it's happening, the adsorption. So that's why it's important to have 145 psi air compressor. Can you use less? Of course, yeah. As you can see on 70, even 70 psi, we still gonna get nitrogen. It's still gonna work, but not as it intended. So take it into consideration, yeah. And when you have at your factory, for example, 100 psi air compressor, 120 psi air compressor. So and always I've been always asked, will it be enough? It might be enough, but it's not gonna get exactly all the parameters we are talking about. So, for example, at Gen 100, yeah, we have 99.99, and we have a capacity 31 CFM, and it's gonna be a little bit less. We're gonna lose in the purity, because you see. Why we're gonna lose in the purity? Because not all the molecules of the oxygen gonna stack in the CMS. They will go with the nitrogen molecules, so we're gonna lose some concentration. How much we're gonna lose? You can see it's the difference between 115 psi and 70 psi would be 290 and 460. So it's quite significant, almost double the production of the nitrogen. So we're gonna get either less purity or less capacity. So yeah, you have to consider it, and this is the pressure, yeah. And please don't confuse it with the CFM, which is the flow. So flow is a different thing. You remember we spoke about the pressure, so that here in a small bottle and in a 5,000 gallon tank, it's gonna be the same pressure, 10 psi. But this is obvious that they have different amount of gas or liquid inside of it, yeah. And you have to be careful when you have 145 psi air compressor on site. It's important to understand how much they give. So we can easily calculate it how much, what is the CFM, because just taking a look at the data sheets of the air compressor, or just by knowing the model. Even we don't know the model, we can see the motor which is inside of it, and usually for the certain amount of kilowatt or horsepower of the air compressed of the motor, we can calculate how much it gives us the flow. And flow, we are calculating in CFM, cubic foot per minute. So this is actual flow. It's how much the gas, how much molecules we have. Yeah. So one point is the pressure, which is the topic of this video, is the pressure. Yeah. It's how much it's pressing the surface of the tank. And the different thing is the flow. So we need to have a certain amount of flow. And by the way, as talking about the pressure, air compressors, sometimes they build and can only give 120 psi or 145 psi, but very often you can actually switch it in the settings of the air compressor. So we can always look at the data sheets of the air compressor, or take a look inside the menu of the air compressor. So very often you can change these pressure settings. And don't forget that at 120 psi and 145 psi, the same air compressor will give you different flow. This is also very important, yeah, that's the flow is gonna be different. And we should always check it. So one thing is the pressure is gonna stay all the time like the same, yeah, but the flow will vary a lot. Depends on how big your air compressor is. So in conclusion, I will repeat once again, pressure is something, it's how strong the gas is forcing the tank's surface, which is it consists of. We need 100 to 120 psi for work the most efficiently. You see 120 psi. We need this, and the flow. We need the flow. So the different aspect of this is the how clean air is and how dry is it. But this is for the next video. We will discuss it in the next video. So yeah, if you have any question, we have call us or text us in contacts in the description below. Yeah, and we are here to help you with the nitrogen. Bye.